Let us suppose we have a triangle whose vertices have the coordinates x1, y1, x2, y2 and x3, y3. Then the area of this triangle will be given by this formula where we half multiplied to the absolute value of x1 multiplied to y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. We'll try to derive this particular formula. So let's take the help of a diagram. So here we have our Cartesian plane with the x and the y axis. We also have a triangle. Let's name the triangle on the vertices being A, B and C. So A, let us suppose that the coordinates of A are x1 and y1. Coordinates of B are, let's say, x2 and y2. And coordinates of C being x3, y3. Next, what we'll do a construction. From each of the vertices, we're going to drop a perpendicular on the x-axis. So let's suppose the perpendicular drop from vertex B on the x-axis meets it at the point M. The perpendicular drawn from vertex A meets the x-axis at L. And then the perpendicular drawn from vertex C meets the x-axis at N. Now immediately we can see here that we get trapeziums. Now one of the trapeziums will be MLAB. The next trapezium would be ALNC, and then the third trapezium will be BCNM. Now taking the help of these three trapeziums, we can easily find out the area of the triangle. All we have to do is find out the individual area of each of the three trapeziums. So if we consider the trapezium A, the area of the trapezium ABML, and add it to the area of the trapezium ALNC, that's going to give us the area of ABMNC, this quadrilateral. But this area of the trapezium BMNC, that's an extra part, so we'll have to subtract that portion from it, and that's going to give us area of the triangle ABC. So let's write it down. So we have area of triangle ABC equals to area of trapezium ABML added to area of trapezium ALNC, and from the combined area we're subtracting the area of the trapezium BMNC. Now what we'll do, we'll try to find out the area of each of the trapezium. So to find out the area of a trapezium, we'll use the formula half times the sum of the opposite sides times the altitude. Altitude will be the distance between the two opposite sides. So we'll start with ABML, that's the trapezium. So area of trapezium ABML. So from figure, it will be half multiplied to, so what will be the sum of the opposite sides? But we have to be careful, opposite parallel sides. So clearly BM is parallel to AL. So here we'll have BM added to AL. That will be the sum of the opposite and parallel sides. And what's the altitude? That means the distance between the two parallel sides. That's simply ML. So we have half BM plus AL whole multiplied to ML. So that's going to be the area of trapezium. Similarly, let's find out the area of the next trapezium. So area of trapezium ALNC, that's going to be half multiplied to sum of the opposite parallel sides, that is AL added to CN multiplied by the perpendicular, the altitude between them, which is LN. Fine. And then finally, we'll find out the area of trapezium BMNC. So for the trapezium BMNC, we have half multiplied to the parallel sides of BM and CN. So we have BM added to CN. And the perpendicular distance between the two parallel sides will be M times N, MN. Fine. Now what we'll do, we'll write the length in terms of x1 and y1. So let's start with the area of trapezium ABML. Here we have half BM. So what's BM? The BM, that's the height, which is given by y2. So that will be half multiplied to y2 added to AL. So AL, the height of the coordinate point A, that's simply the y coordinate. So that's y1. And this will be multiplied to ML. So what is ML? So from the origin, if we go till the point L, so that's the distance of point L from the origin. So that's simply x1. So we have the total length x1, but what we need here is ML. We only need this particular length. So we will subtract OM from it, and OM clearly is the distance of point M from the origin, and that's simply the x coordinate, which is x2. So we have x1 minus x2. Fine. Similarly, coming to the area of trapezium ALNC, we have half multiplied to AL. So what is AL? AL is the height of point A, which is the y coordinate. So we have y1 added to CN. So that's the height of point C. That's going to be the y coordinate, y3. Multiplied to ln. So ln will consider the distance of n from the origin, which is going to be the x coordinate, x3. And from it, we are going to subtract the distance of L from the origin, which is nothing but the x coordinate of point A. That means x3 minus x1. And then coming to the area of trapezium BMNC, we have half multiplied to BM. So BM, that's the height of point B, which is the y coordinate. We have y2. Added to CN, height of point C, that's going to be the y coordinate, y3. Now we need Mn. So Mn will take the entire distance from point O till N, which is the x coordinate, that's x3. And from here, we're going to subtract OM. So OM will be the distance of M from the origin, which is nothing but the x coordinate, x2. So we have x3 minus x2. Now we'll be using these values and substitute them to find out the area of the triangle. So let's do that. All we've done is added the area of the two trapeziums. This is for ABML. This is the second trapezium, ALNC. And from here, we have subtracted the trapezium, area of the trapezium, BMNC. So let's further simplify this, and we will now get, so we have half common in each of them. So we have half. Now we will multiply y2 plus y1 with x1 minus x2. So we have y2 times x1 minus y2 times x2 plus y1 times x1 minus y1 times x2 plus we have y1 multiplied to x3 minus x1. So we have y1 x3 minus y1 x1 plus y3 x3 minus y3 x1. Then we have the minus y2 x3. Then we have negative y2 x2. So we are going to multiply with negative sign to make it positive. So we have positive y2 x2. Then we have negative y3 x3 plus y3 x2. Fine. Now a couple of terms will get cancelled out. So let's see which of the terms get cancelled out. We have negative y2 x2 and positive y2 x2 cancelling out. Also, we have positive y3 x3, negative y3 x3, and then we need one more, positive y1 x1, and we need negative y1 x1. Fine. So let's combine all the like terms together. So we are going to take x1 as the common factor. So we're going to combine this term and this term. We'll take x1 as the common factor. So x1 gets multiplied to y2 minus y3. Then we're going to take x2 as the common factor. For that, we are going to pick up this term and this term. So we have y3 minus y1. And then finally, we're going to take x3 as the common factor. So we'll take this and this term. So we have y1 minus y3. Now, depending upon the values of x1, x2, x3 or y1, y2, y3, this entire value within the parentheses, that could be negative also. But we know that the area of a triangle, that's always positive in nature. So area of triangle ABC, finally, in order to take care of the negative sign, what we'll do, we'll only consider the magnitude. So we'll take half, then multiply to the magnitude of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 multiplied to y1 minus y3. So this is how we can find out the area of a triangle if the coordinates of the vertices are given to us. So let's try to implement this particular formula with the help of few examples. So here we have the problem. What will be the area of a triangle whose vertices are given? So let's try to solve this problem. So here we have the point A given by 3, 2. So we have already considered that A corresponds to x1, y1. That immediately tells us that the value of x1 is going to be 3 and the value of y1 will be equals to 2. Fine. Coming to point B. So B, we are given the coordinates 11 and 8. So we'll consider it to be equivalent to x2, y2. such that we have x2 equals to 11 and y2 equals to 8. And then coming to point C, C has the coordinates 8 and 12. So that means if we make it equivalent to x3, y3, this would mean that x3 is going to have the value 8, where y3 is going to have the value 12. All we have to do is to find out the area of the triangle ABC. We'll use the formula half. So let's try to recall the formula. We'll have to take the magnitude. First, we'll start with x1, then this will be multiplied to y2 minus y3. Added to, we'll take, and next will be x2 multiplied to y3 minus y1. And then we have x3, this will be multiplied to y1 minus y2. All we have to do is substitute now the values in their respective position. So x1 will be 3 multiplied to y2. So y2 is 8. We have 8 minus y3, so that's 12. Added to x2. So x2 is 11. 11 multiplied to y3. So y3 is 12 minus y1. So y1 is 2. Added to, we have x3. So x3 corresponds to positive 8 multiplied to y1. So that's 2 minus y2. So that's 8. Okay, now we will find out the value. So we have half multiplied to 3 times. So 8 minus 12, that's negative 4. Plus 11, then 12 minus 2 will be 10. Added to 8 times 2 minus 8, so that's negative 6. So this will be half multiplied to negative 12 plus 110 minus 48. So 48, negative 48 and negative 12, that's negative 60. So 110 minus 60, so that's going to be 50. So we are left with half multiplied to absolute value of 50, which is simply going to be 50 only. So that means our area comes out to be 25 square units. Fine. Now I'm going to show you an alternate way to calculate the area quickly. So here we are given, so let's do it. So here we have the vertices of the triangle A, B and C. The alternate method will be to find out the area. So area of triangle A, B, C. So that's going to be equals to, we'll have to take the half. Now instead of remembering the formula, all we have to do is take the absolute value. Now in the first row, we'll start with the coordinates of A. So that's 3 and 2. Then we start with the coordinates of B in the second row. That will be 11 and 8. Then we'll start with coordinates of C. So that's 8 and 11. Now that we ended with C, we'll come back to A. So since we started from A, we'll have to come back to A. So that will be again 3, 2. Meaning if we had started out with coordinate point B in the first row, then we'll come and the next row will have the coordinates of C. Third row will have coordinates of A. And finally, we'll again come back to B since we started out with B. Okay, now what we'll have to do is we'll multiply 3 with 8. 11 with 12 and 8 with 2. And then we're going to multiply 11 with 2, 8 with 8 and 3 with 12. Now there's a particular way of doing the multiplication. So we have half, we have absolute value. So we're going to take the multiplication of 3 and 8. So we take 3 times 8. So we'll start from this particular position. Then we'll add this to 11 times 12. 11 times 12 added to 8 times 2. And we are going to now subtract again the same method. So now we will multiply 11 with 2. 11 times 2 added to 8 times 8 times 8 plus we have 3 times 12. 3 times 12. So if you forget the formula, this is also going to give you the same result. So we have 24 plus 132 plus 16. So we are going to sum it up and then from it subtract 11 times 2, that's 22, plus 8 times 8 is 64, plus 12 times 3, that's 36. So let's find out this value. So this will be equals to, we have half, then 172 minus 122. So 172 minus 122, that's going to be 50. So 50 being a positive number, we'll only consider positive 50. So 50 over 2, that's going to be 25. So we're getting the same result. So we can use either method, the general method. So general method will be using this particular formula and plugging in the values of x1, x2, x3 and y1, y2, y3 in the respective position to get the area of the triangle as 25 square units. Or we can use this other method to quickly get into the result. Let's move on to the next problem. Let's discuss collinearity of 3 points. Collinearity means the points that are lying on a same line. So we started out by finding out the area of a triangle. So we've already defined the area of the triangle whose vertices are known. Now, collinearity means that the 3 points must lie on the same line. Now think about it. If we consider this particular point A, which is the vertex, if we drop it such that it lies on the line joining B and C. Let us suppose that this is the new position of point A. Then in that case, we have no area. So this is just a straight line. This area of this particular triangle must be equals to 0. So we get a new condition. That means if the area of triangle ABC equals to 0, so that means this right hand side must also go to 0. So we have half times, so this must be equals to 0, and half cannot be equals to 0. So we're left with the condition x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2, and we take the absolute value. So this is going to be equals to 0, or the faster way to calculate it will be, so we will consider the absolute value. In the first row, we will start with A. So we have x1, y1. Then we have x2, y2, followed by x3, y3. And then we have x1, y1. So we started out with x1, y1. Now, the same method, we'll take x1 and multiply it with y2. Then we take x2, multiply it y3. And we take x3, multiply it with y1. Now, we'll take x2, multiply it to y1, x3 gets multiplied to y2, and x1 gets multiplied to x3, and this value must be equals to 0. Fine. So how do we find out this value? So we'll start with this particular position. So we have x1 times y2 added to x2 times y3 plus x3 times y1. And from here, we're going to subtract x2 y1 plus x3 y2 plus x1 y3, and this will be equals to 0, and we'll take the absolute value here. So this is the condition for collinearity of 3 points. Let's try to understand this with the help of an example. So here we're provided with 3 points: A with coordinate 2, -2, B with coordinate -3, 8, and C with coordinate -1, 4. We need to show that the points are collinear. So let us begin. So here, let's do one thing. This time we start with point B. So we have the coordinates of point B, -3 and 8. Then followed by, after B, we'll get C. So that's -1 and 4. Then we'll consider A, which is 2, -2, and then we'll come back to point B. So we have -3 and 8. So we'll try to compute this particular value. First, what we'll do, we'll multiply -3 with 4. So -3 times 4, that's going to be -12. Added to -1 times -2. So that's going to be +2. Added to 2 times 8. So that's going to be 16. So from here, we're going to subtract -1 multiplied to +8. So that's going to be -8. Added to it will be 2 times +4, so that's simply +8. And then we have added to it will be -3 multiplied to -2, which is +6. So we have -12 plus 2, that's -10. 10 added to -10 added to +16 makes it +6. Minus, we have -8 and +8 cancelling out, we have 6. So we are finally getting 6 minus 6, which equals to 0. So we have successfully showed that these 3 points, so therefore points A, B, and C, these 3 points are going to be collinear. Let's move on to the next problem. So problem number 3, we need to find out the value of x such that these 3 points lie on a line. In other words, these 3 points are collinear in nature. So that's a very simple problem. All we have to do is take the magnitude, and within the magnitude, we'll start with x and -1. In the next row, we have 2, 1. Then in the third row, we have 4, 5. Since we started out with the point x negative 1, so we'll end up with x and negative 1 in the last row. This must be equals to 0. So let's compute the value. So we have x multiplied to 1, that gives us x. Then we have 2 multiplied to 5, so that's going to be 10, so we're going to add 10 to it. And then we have 4 multiplied to negative 1, so that's negative 4. So we subtract negative 4 from it. So this is going to be one set, and from here we're going to subtract. Let's take the product of 2 and negative 1, which is going to be negative 2. To it we are going to add the product of 4 and 1, which is simply positive 4. And then we have the product of x times 5, so that's 5x, and we're going to add this to the rest. This will be equals to 0. So let's find out the value. So we have x, 10 minus 4, that's going to be positive 6. Minus, so we have negative 2 plus 4, so that's going to be positive 2. So we have 2 plus 5x equals to 0, which gives us x plus 6 minus 2 minus 5x equals to 0. So we have x minus negative 5x, so that's negative 4x. Then we have 6 minus 2, that's going to be 4 equals to 0. Solving for x, we get the value x equals to 1. Now that means for x equals to 1, there's 3 points are going to lie on a line. That means they are going to be collinear in nature. Let's move on to the next problem. So here we need to find out the area of a quadrilateral whose vertices are provided to us. So let us begin. Let us suppose we have a quadrilateral here. The quadrilateral has the vertices A with coordinate 1, 1. Then another coordinate of the vertices B will be 7, negative 3. Coordinate of vertex C would be 12, 2. And coordinate of vertex D would be 7, 21. So our goal will be to find out the area of this quadrilateral. That's a very simple problem. All we have to do is we can join point A and point C. And that's going to divide the quadrilateral into 2 triangles. Or what we can do, we can join D or B, whichever way you do, you'll get the same result. So here in this case, I'm joining vertex A and C. That's giving us 2 triangles, that meaning area of the quadrilateral A, B, C, D, that will be simply equals to half of area of the triangle. We'll consider the upper triangle, so that's ABC, and add it to the lower triangle, which is area of triangle ADC. So our goal will be to find out the area of each of the triangles independently. However, I'm going to show you a different way of finding out the area of quadrilateral. So area of the quadrilateral ABCD, half multiplied to, so we will take the absolute value. In the first row, we'll start with coordinate of A. So that's 1, 1. Then we have the coordinate of B, that's 7, negative 3. So we'll place it in the second row. Then we have C with coordinate 12, 2. That goes to the third row, followed by coordinate of D, so that's 7, 21. And since we started out with coordinate values of A, so we'll have to end with A. So that's 1, 1. Now let's try to find out the value. So here we have half multiplied to, so we'll start with 1 times negative 3. So that corresponds to negative 3 added to 7 times 2. So that's 14. Then we have 12 times 21. That corresponds to 252. Added to 7 times 1. So that's simply 7. And then we're going to subtract 7 times 1. So that's 7. Added to 12 times negative 3. So that's negative 36. We have 7 times 2. So that's 14. And then we have finally 1 times 21. So that's positive 21. Fine. When you compute this value, this comes out to be 270 minus 6, which is simply half multiplied to 264. So 264 divided by 2, that's 132 square units. Now that means the area of the quadrilateral is going to be 132 square units, and you can confirm that this is also equals to this the same method. If we take the area of the 2 triangles, the upper triangle and area of the lower triangle, add that, and it also is going to give us 132 square units. So this is how we can use the formula for finding out the area of a triangle or a quadrilateral.